Now that we've shown you the parts of the system, let's take a look at how they all fit together. First, let's begin at the fluid reservoir and mixing system. Here in the mix system tank, we have the two floats. When the fluid level gets low enough, the upper float lowers and opens the fluid level control switch. Rig air, regulated to 100 psi, passes through the switch to operate the quarter-inch air control valve. It opens and allows rig air to pass to the 2-inch regulator control valve and barrel pump. The 2-inch valve opens and allows pot water to pass on toward the mix tank. The barrel pump begins pumping concentrate toward the mix tank. The concentrate and pot water meet and mix just before they enter the mix tank. As the tank fills to the proper level, the float rises and shuts off the fluid level control switch. Air stops to the quarter-inch air control valve, and air can no longer get to the 2-inch regulator control valve and barrel pump. Potable water and concentrate no longer enter the mix tank. The lower float and fluid level control switch work in the same manner. If the fluid should ever drop below the level control switch limit, air passes through the switch to junction box number 3, which houses the pressure switch for the low-level fluid alarms. The air pressure activates the switch and sends voltage to the driller's control panel, illuminating the low-level fluid warning light and activating the audible alarm. Let's take a closer look at the potable water flow path. Once pot water enters here, it passes through this Y-type strainer. This gate valve remains normally open. You can close it if you need to make repairs to the mix system downstream. Next, it passes through this water pressure regulator. Then it's stopped here by the 2-inch regulator control valve. This valve is a normally closed valve. It opens when the air control valve supplies it with air. Recall that this happens when the upper level fluid control switch opens, sending air to the air control valve and barrel pump. From here, the pot water passes through the flow rate indicator. As the name implies, the indicator tells us how many gallons per minute are entering the mix system. This final gate valve is the water rate valve. With it, you adjust the rate of flow into the mix piping. Again, recall that the barrel pump receives its air power from the air control valve also. The rate at which the barrel pump strokes is controlled by this needle valve. So, to keep that all-important mix ratio of water to concentrate accurate, the water rate valve, the water pressure regulator, rig air, and the barrel pump output valve must be in proper adjustment. Speaking of pumps, let's move on to the triplex kind. The triplex pump is chain-driven by this electric motor. The motor receives its voltage by either of two methods. First, we have the motor control box, the primary control for the motor. When left in the off position, voltage cannot get to the motor. Turning the switch to the hand position allows the motor to drive the pump continuously until you turn it off. Be careful with this. Overpressurization of the system can occur if your relief valves haven't been tested or serviced in a while. Turning the motor control box to auto brings the second method of control into action, the hydroelectric automatic pressure switch. It's electrically wired to the motor and motor starter and hydraulically connected to the main accumulator system. Its settings for maximum and minimum pressure are adjustable here. In a 3,000 psi system, the minimum pressure is set around 2,900 psi, maximum at 3,100. In a 4,500 psi system, they'll be set at 4,400 and 4,600. When hydraulic pressure drops to the adjusted pressure setting, the pressure switch electrically closes and signals the starter to activate the pump. When hydraulic pressure reaches the proper level, the pressure switch opens and the pumps turn off. That's how the pumps are turned on and off during normal operations. So how does the mixed fluid get to the pumps? The reciprocating motion of the plungers creates a pressure reduction inside the fluid cylinder. This reduction in pressure allows atmospheric pressure, acting on the reservoir, to push fluid through the suction strainer into the suction end of the pump. Fluid leaving the other end of the pump passes through the check valve. This valve prevents the possibility of backflow into the pump from the pressurized accumulators. The triplex pumps are backed up by the air-operated pumps. These activate in the event the electric motors or triplex pumps fail. They also help to overcome fluid losses in the event that main pumps cannot keep up with a possible leak or fluid flow. Rig air enters the pump here after passing through this air lubricator. During normal operation, airflow is prevented from driving the pump by the hydro air pressure switch. Accumulator pressure pilots the hydro air pressure switch. When accumulator pressure piloting the hydro air pressure switch becomes less than the adjusted spring force opens the pressure switch and allows the air to flow and drive the pump. Hydraulic fluid coming from the mix tank passes through this shutoff valve, through the suction strainer, and into the suction end of the hydraulic pump. Fluid leaving the pump passes through a check valve into the accumulator system. The check valve serves the same purpose as that in the triplex pump system. When system pressure is back to normal, hydraulic pressure overcomes spring force and closes the pressure switch. Air is no longer delivered to the pump. When opened, this valve allows you to bypass the hydro air pressure switch. Air goes directly to the pump. The pump increases system pressure until you close the valve. Fluid passing the check valves from either the triplex or backup pumps enters the piping that carries the fluid to the high-pressure filters. One 10-micron and two 40-micron filters make up the assembly. Each filter is provided with shutoff valves upstream and downstream of the filter. Under normal operation, the valves remain open and fluid passes through the filters. As the fluid passes through the filters, it then enters the main surface accumulators and the accumulators designated for pilot fluid. These are the system's maximum pressure relief, or pop-off valves. In the event the hydroelectric automatic pressure switch or hydro air pressure switch fails, system pressure increases. The relief valves will open and allow fluid to flow to tank until the problem can be corrected. Hydraulic fluid leaving the main accumulator banks enters the control manifold and passes through the flow meter. From there, it is directed by the 1-inch pod selector valve. This valve directs main hydraulic supply fluid to either the blue or yellow RBQ junction box. At the same time, the pilot accumulators supply fluid to all of the 1/4-inch four-way valves on the control manifold. In this particular system, two check valves isolate the pilot accumulator bottles from the main hydraulic supply. These check valves allow the pilot accumulators to maintain pilot pressure even if the main accumulator system fails or is shut down. At the back of the manifold, all of the supply ports are interconnected. So are the return to tank lines. Each of the function ports directs fluid in two paths. First, to junction box number 1, which houses the pressure switches. That turns the lights on and off at the drillers and many remote panels. Second, they direct fluid to the RBQ junction boxes. The flow path of the fluid leaving these 1/4-inch valves differs from the pod selector valve. The pod selector directs supply fluid to either the yellow or blue RBQ, never both at the same time. When pilot fluid leaves the 1/4-inch four-way valves, it goes directly to both RBQ junction boxes at the same time. In other words, if the four-way valve for upper rams is shifted to the open position, pilot fluid goes to the appropriate connection in both the blue and yellow RBQ junction boxes. Here we have the AKRs, the valves we rely on to increase and decrease the hydraulic pressure settings of the subsea valves that control the pressure to the various stack functions. Like the pod selector valve, they receive their supply from the triplex pumps and main accumulator banks downstream of the flow meter. At the outlet, the regulated hydraulic fluid is routed in 4 directions: to the blue RBQ junction box, to the yellow RBQ junction box, to a pressure transducer in junction box number 1, and to the appropriate gauge on the pressure gauge assembly. The transducer in box number 1 transforms hydraulic pressure into an electrical signal, driving the meters on the driller's panel. To manually increase or decrease one of these regulators, first shift the selector switch to the unit position. When increasing, this sends air from this manual air regulator through the selector switch to the AKR diaphragm. When decreasing, air leaves the AKR, goes back through the selector switch, and vents at the manual air regulator. An important point to remember here: before you shift the selector switch to unit, make sure the manual adjustment is cranked up. You'll ensure that the regulator won't bleed down to zero when you throw the switch. Since accidental loss of air on the diaphragm of the AKRs can result in loss of pressure to the control fluid of the BOP components, some rigs have begun replacing the AKRs with these newer Koomey TR valves. The TR valve is a manual regulator with an air motor drive. The air motor operates from the increase-decrease solenoids and controls the manual operator of the valve. However, if the air pilot should fail, the manual operator maintains its last setting. Leaving these selector switches in the remote position will allow you to control the pressure settings from the driller's or many remote panels. If your driller's panel has a push and hold to operate button, you'll have to push it at the same time you push any function button in order for it to work. All of the buttons on this panel are momentary function switches. This means, of course, that the electric circuit is complete only as long as you hold the button. Release it, and the voltage is turned off. In the remote panel position, let's look at what happens when you operate an increase function. Pushing the increase button on the driller's panel energizes the increase solenoid in the solenoid junction box. Regulated rig air passes through the increase solenoid, through the check valve, and to the air diaphragm in the AKR. The airflow increases the regulated output of the AKR until you release the increase button. Once you release the button, the check valve on the increase solenoid prevents the air in the AKR diaphragm from venting back through the increase solenoid vent port. Pushing the decrease button energizes the decrease solenoid, allowing air in the AKR diaphragm to vent through the decrease solenoid and outside of the junction box to atmosphere. Many of the functions on the driller's panel have 3 push buttons, like this lower annular: open, block, and close. Let's see what happens when we push the buttons. Pushing the open button sends a voltage to the lower annular open solenoid in junction box number 2. Air passes through the solenoid and flows to the appropriate 3-position air cylinder. Air pressure, acting on the rod end of the cylinder, retracts the rod, and by means of the mechanical linkage, shifts the 4-way valve handle to the open position. At the same time that air passes through the open solenoid to the rod end of the cylinder, the air on the piston end is venting through the close solenoid. Releasing the open button de-energizes the open solenoid, stopping the airflow. Pressure in the line vents. Just like pushing the open button, pushing the close button energizes the close solenoid, allowing air to act, this time on the piston end of the 3-position air cylinder. The rod extends, shifting the 4-way valve handle to the close position. Air on the rod end of the cylinder passes through the de-energized open solenoid and vents. Since these buttons are momentary function switches, if you release the button, the voltage to the solenoid stops, so air to the cylinder stops. If you release the button too soon, the 4-way valve may not have had time to fully shift. The open, close, or unlock lock buttons all have indicator lights inside the buttons. They will turn on to indicate that the 4-way valve has shifted to the selected position. However, it's important to understand that these lights turning on or off is not a direct result of pushing the button nor of the 4-way valve handle shifting into position. The indicator lights receive their voltage from an entirely separate circuit than that which powers the solenoid to shift the 4-way valves. As mentioned earlier, each cylinder port on the back of the four-way valve is connected to a pressure switch in junction box number 1. When a valve is shifted to open, pilot fluid flowing through the respective lines immediately begins increasing in pressure. As the pressure in these lines increases to the set range of the pressure switch, this pressure switch senses the pressure and completes the circuit that turns on the indicator light. Just as the increase in pressure results in the pressure switch completing a circuit to turn the light on, the reduction at the close pressure switch results in the close light turning off. It is possible for pressure to increase to the range of the pressure switch, turning on the indicator light, even though the four-way valve may not have completely shifted. A sticky mechanical linkage, someone using the four-way valve as a hat rack, or not holding that push button for a few seconds after the indicator light has come on could cause a partial interflow of that precious pilot fluid back to tank. Even if you hold that button for a few seconds after the light has come on, be aware that the four-way valve may not have completely shifted. In explaining the operation of the block button, it'll be necessary to show the two possibilities that exist. First, we have the Koomey systems manufactured by N.L. Schaefer. Pushing the block button at the driller's panel completes a circuit that sends a voltage to both the open and close solenoid. Both solenoids open and allow rig air to act on the piston end and rod end of the three-position air cylinder, which moves the rod halfway between fully extended and fully retracted. The four-way valve, by means of the mechanical linkage, is also forced to the center or block position. The indicator light inside of the block button turns on as a result of removal of pressure from both the open and closed pressure switches at the same time. Something to keep in mind when pushing the block position on the driller's or mini remote panel. Pushing the block button energizes both solenoids, open and close. If it so happens that the open solenoid is inoperative when you push block, operating the system could close the ram or annular that you functioned. Be sure and think about what's going on downhole before you push the block button. The Koomey system, manufactured by Koomey Incorporated, utilizes a third solenoid for the block position. Pushing the block button energizes the block solenoid, which allows air to pass through two shuttle valves. Acting on both ends of the cylinder, air shifts the four-way valve to the center position. Like the N.L. Schaefer system, the block light turns on as a result of removal of pressure from both the open and closed pressure switches at the same time. Both systems utilize a memory circuit when the block button has been pushed. Using a series of electrical relays, voltage continues to flow through the circuit to the last functioned push-button indicator light, even though hydraulic pressure to the respective pressure switch has been removed by going to the block position. This allows us to glance at the panel and know exactly what position a BOP component was left in prior to pushing the block button. The memory circuits are located in the mini remote panel. This panel is most often installed in the tool pusher's office. It remotely operates the hydraulic control manifold exactly as the driller's panel does. The mini panel, the driller's panel, and the hydraulic control manifold are wired together in such a manner that the indicator lights and the four-way valve handle positions correspond and almost simultaneously reflect the position of the various BOP components, regardless of which station is being operated. So, that's how the Koomey unit and its components operate. Now, take a look at your own unit. You should be able to identify the various parts and know how the integrated control system operates. Next up, that all-important subject of maintenance.